Now let us see what are the open issues in next generation hybrid architecture. So after all the three types of basic hybrid type of network, so there are many advanced hybrid networks. So what we explained just now, that is MCN, HWN, and Soprano. They are the very basic type of hybrid networks invented long back. So after that, let us see what are the main open issues in next generation hybrid architecture. So there are around 13, 14 different issues. We'll be discussing one by one. Major 6 to 8 points we will discuss, and after that, the remaining issues I will just list down. So these are actually challenges that the next generation hybrid architecture must address to meet the expectations of emerging applications and growing number of users. First issue is flexibility. Okay. So hybrid network architecture must be highly flexible because it is mixing infrastructure based as well as infrastructure less type of network. So in flexibility, what we can see is there's a keyword for next gen wireless network. Here the users are provided ubiquitous access to information and data irrespective of their physical location. So every user should be able to access whatever data they want to access and information whatever they want to access. This is flexibility and this kind of a freedom given to the user. So transparent handoff to various heterogeneous networks is necessary to make it happen. So not necessary that only one type of communication paradigm is used. Different networks might be using different types of paradigm, but all these different types of communication protocols should be brought together under the same type of network, and this is difficult. Okay. But next gen, whenever we are designing network for next generation, we should be able to put together heterogeneous types of networks to form a bigger network which is used by many users. So number of users are going to increase. In that case, it will be asking for more flexibility of the network. User preference may influence the handoff parameters and decisions that is there. For example, while a particular user prefers to use networks based on cost of access, other might prefer to get minimum handoff at a higher cost operation. So yes, some users performance might be the highest criteria. So if it's a BPO, if it's a software company and all those things, for them internet connectivity without any interruption is the main criteria. So for that, whoever is the network service provider, if they're using a little bit more, the company is ready to pay it. But for a common person, the cost of data, whatever 1 GB data, 2 GB data, whatever data he is using. Okay, so for a common person, the cost of data is the main issue. Okay, so that's what it is saying, that while a particular user prefers to use network based on cost of access, others might prefer to get minimum handoffs or at a higher cost of operation. So somebody might go for best operation with higher cost. Somebody might go for lesser cost as the prime parameter with a little compromised quality of service. Okay, so different users are having different criteria, different choices. Okay, so hybrid architecture should be able to cater all. So in the context of next generation hybrid wireless networks, flexibility refers to the freedom provided to a user to work either in the infrastructure mode or in ad hoc mode where the infrastructure is always present. So it has to be chosen by the user whether he wants to work in a infrastructure based cellular kind of a network or infrastructure less ad hoc kind of a network. That choice should be given to the user itself. A user can choose to work in the unlicensed band for communication when he finds that he can reach the node without any support from the fixed infrastructure. So there are some licensed band and there are some unlicensed band. If unlicensed band communication is making communication easy, in that case the user should be able to access the unlicensed band and should be able to communicate through that. There should not be any another flexibility added to the network. Since the network nodes can use the unlicensed band of the radio spectrum, the cost of communication is reduced. Obviously, unlicensed band communication is less costly. So if somebody doesn't want to use the standard cellular type of communication, he or she wants to use an unlicensed band with a lesser cost, the hybrid network should be able to communicate, should be able to allow that person to use the unlicensed band. Okay, so that is actually the offering flexibility. When a user finds that the intended recipient of his information is not reachable directly, that means the sender is not able to contact to receiver directly. In that case, he can opt for using the support of available infrastructure by registering with one or more available service provider. That means if suppose a Vodafone customer, he is trying to reach his Vodafone receiver, and he is not able to contact to his Vodafone receiver, maybe that receiver has gone into the zone where Airtel is more strong. So directly Vodafone will be able to connect to that receiver by using Vodafone initially and then Airtel connectivity. Okay, so that interoperability, okay, by using different networks, by jumping from one network to another network to keep the connectivity intact. Okay, so that kind of flexibility should be offered to the user even in the presence of the service providers. So Airtel, Geo, Vodafone, they are all service providers. Even in the presence of service providers, one can opt for connection to the service provider either over a single wireless hop or multiple wireless hop. So in hybrid network, the user should be able to choose among different service providers. They should be able to jump services from one service provider to the other service provider, and flexibility of data, flexibility of accessing channel, all those flexibility should be offered to the user in next generation hybrid architecture. Pricing scheme. Okay, this is another very important thing in case of hybrid network architecture. It says that in traditional cellular network, pricing is a simple problem for which straightforward solution exists. Like 1 GB data is for suppose 50 rupees. Yeah, so this is a kind of a linear solution of a problem. But in case of Soprano, the relaying is done by dedicated relay stations which are under the direct control of BS. So we have seen just now what is Soprano. So there we had seen two cells. So in one cell there was a base station one, there were a lot of relay nodes, and there were a lot of mobile hosts. Okay, so relay nodes are actually controlled by the base stations. So once we're using Soprano kind of architecture, here the existing pricing scheme can be used without major changes. But in the hybrid wireless network architecture, the relaying is done by the intermediate nodes which expend their own resources such as battery charge and buffer, and hence they should be paid for the services rendered. So whenever it is totally controlled by base stations like mobile phone, whatever network we are using, okay, base station is the main thing who is charging us. So we are being charged actually for the operation of base station. But if you have seen Soprano, in case of Soprano, it is not only the base stations, but also there are some intermediate repeater nodes. Okay, they are wasting their bandwidth, they are wasting their battery usage, battery. Okay, so for that they can ask for some charge from the user, whoever is using that network. So that is what the name of Soprano has come, because in case of Soprano, all the intermediate nodes, they are controlled by the base station. So it is not only the base station who will be charging the users of Soprano, but the intermediate relay nodes, repeater nodes, they can also charge the user for the service that they are offering. That is what they are saying. In the hybrid wireless network architecture, the relaying is done by intermediate nodes or repeater nodes, which expend or spend their battery, their resources, bandwidth, and buffers. Hence, they should be paid for the services that they are rendering or offering. Architectures such as HWN. So HWN we have just now seen there are two types. One is cellular mode, one is ad hoc mode. Okay. So in HWN architecture, which operate both in cellular and ad hoc mode, require new pricing schemes when they operate in ad hoc mode, but can make use of existing schemes while operating in cellular mode. So we have seen there is something called a switching. Okay, so continuously there goes an algorithm that if A and B node are there in two different positions, which architecture will be better, or which architecture will be less costly, will be costing less amount of power, whether it will be a cellular type of architecture or whether it will be ad hoc type of architecture. Okay, and depending on that, the cost of network usage also has to change. That is what they're saying, that new pricing scheme when they operate in ad hoc mode, but can make use of existing scheme while operating in cellular mode. So both these two things should be charged differently. Okay, so new multi-hop pricing schemes such as the one proposed in here are required for this architecture. So one network, one type of pricing is not proper. That is what is the open issue in case of next generation hybrid network. Like we have seen in case of Ola cab and Uber cab. Initially it was not there, but now they have brought the characteristic of dynamic pricing. What is dynamic pricing? Whenever the demand is too high, at that time per unit cost will be too high. Okay, so in that case, 4:30, 5 o'clock in the afternoon, when demand for cabs and all these things are very high, at the time the per unit charge also will increase. So this is also called as dynamic pricing. But whether it is suitable for the user or not, that we have to see. So for the same time, initially there used to be offers that throughout the night, so from night 11 o'clock to morning 6 o'clock, whatever calls you make inside India, they were all free. Okay, so STD and all those things becomes free all over India. So that is actually a time-based kind of a solution that the service providers used to provide. So all these features, pricing scheme and flexibility, all these features are being included in the next gen hybrid network. Third is multimedia support. So support for multimedia traffic in hybrid wireless network architecture is in a very early stage when this book was written, actually, the book of Murthy. But now it is quite advanced. Okay, so multimedia means we can talk about video, audio, text, data, images. So all this data should be very easily transferred without any kind of fault from the transmitter to the receiver. So at the time when the book was written, at that time it was early stage, but now it has advanced quite a lot, especially for the packet-based systems. The research has advanced quite a lot. Okay. So better multi-hub scheduling with or without assistance from the base station is required for this purpose. Okay. So without the support of base station means it's an ad hoc type of transmission that is required. Okay. So this problem is more complex in HWN architecture when it's operating in ad hoc mode. So HWN in cellular mode, it is okay because cellular mode is controlled by the base station, and base station can handle multimedia traffic well because base station does not have the constraint of power and bandwidth. But whenever HWN is working with ad hoc mode, ad hoc mode is having the biggest problem of bandwidth and power. Okay, so all these things are constrained in case of ad hoc mode. In that case, multimedia traffic handling might be a big issue in case of a hybrid wireless network. So we have to take care of that. So more research, better technology, and better understanding, better load scheduling can solve this matter. QoS at high mobility. So due to the smaller transmission range and frequent path break due to the instability of relaying nodes, further mechanisms are required to achieve good performance at high mobility. So whenever the node mobility is very high, because it is moving within very short area, so whatever circle was shown in the previous diagrams, okay, so nodes are moving within that. Okay, so even if there is high node mobility, then also even if there is high instability inside the network, then also uh, the path break if happening, it should be the network should be able to maintain the path break. The network should be able to rejoin the paths very fast. Okay, and the fault in the link should not be there, or even if the fault in link comes, that should be able to repaired very fast. Okay, so one thing is link break should not happen. That is the first criteria, even if there is a mobility, but unavoidable. If link break is unavoidable, link break is happening, uh, very soon rerouting or link rejoining should happen. So these are two important things. First case, link breakage should not happen due to mobility. We have seen PBL, QR, and all those things that we can predict where the node is going to end after a certain time. Okay, so accordingly we can keep the link intact between the source and the receiver. But then also, due to huge mobility, if there occurs a link break, after the link break very fast, the network should be able to rejoin the link. Okay, so that kind of route maintenance algorithm should be there. We have seen some 3 4 different types of route maintenance algorithm in the previous and in the second chapter. Please go through that. Dynamic prediction based approaches. So just see what it is saying. So PLBQR, we have predictive location based routing algorithm. We have seen that. That is, dynamic prediction based approaches can be used to take proactive step. Proactive means before the occurrence happen. Okay, before the danger happens, you are proactively taking the rejoining scheme into picture. Okay. So dynamic prediction based approaches can be used to take the proactive steps to reroute the calls before the actual path breaks. So we can predict that if a node is highly mobile, is trying to move too much, in that case we can expect that yes, within a certain 1 minute or 2 minute there will be a path breakage, and before the path break we should be able to reroute, we should be able to plan another path through which the data can be rerouted. So this proactive approach, that is before the catastrophe happen, we should be able to plan for a rerouted path. Okay, so that should be the characteristic of hybrid wireless network of next generation. The path selection process can be modified to select a path which is more resilient to mobility. So another approach is we have to check which are the nodes which might have higher mobility. Okay, so before routing is done, before the paths are selected, we have to select those nodes which might be having very lesser amount of mobility, less volatile. So whenever you are choosing a group for some work, you try to choose good stable people. The people who are highly jittery, people who are highly mobile with high mobility or unpredictability, we try to avoid those people in our group. The same thing whenever we are choosing a route, at the time we try to see that that route is having nodes with lesser mobility. But that is another way of avoiding the catastrophe at the beginning design stage. So that is an open issue in next generation hybrid network. Resource management, very important issue, because ad hoc network is already a resource constraint kind of a network. Okay, so resource allocation is one of the major issues which takes multiple dimensions ranging from pathfinding to the use of a particular mode of operation. So while pathfinding, we have to just check what are the resources in the path. So path means many nodes are connected between transmitter to the receiver. What are the energy, remaining battery charge in the nodes in that path, that we have to check. How much are the bandwidths allocated to each of the node in that path, that we have to check. Okay, whatever links are there, whether those links are congested or not, those links are free or not. Okay, that we have to check. So these are the resources. A base station with its resources and availability of location and state information of the system can effectively be used for this task. So at every stage, the base station has to have the overall network knowledge very clearly. How many nodes are there within within the area of the base station? How many nodes are dead? How many nodes are active? How many nodes are having full charge? How many nodes are having 10%, 20%, 30, 40, 50, 60, 80% charge? Okay, which are the nodes with high mobility? Which are the nodes that can be connected easily, okay, from the base station? Which are the nodes which are trying to go out of the cell? So all this network related data, all this node related features should be updated in the base station. So base station is like the station keeping element. Okay, so it should be having the base station with its knowledge of resources and resource availability, okay, and state information of the system. It can effectively be used for the resource allocation task. The following are some of the major resources which are required for dynamic allocation strategies. So these are very 4 important points. First one is channel allocation. It can be done by TDMA, CDMA, FDMA. If it is done by TDMA, it is called time division multiple access. So in that case, time slot is allocated by the base station. Sorry. If it is CDMA, in that case, code-based allocation is used. And if it is FDMA, in that case, frequency-based allocation is used for channel. Okay. Then next is power control. The transmission power to be used at every hop. We have to check how much is the transmission power at every hop. And if in that case, the K value comes very important. So small r is equal to capital R by K. If k value we are keeping as big, in that case small r value becomes less. In that case transmission hop power will be very less. So that k value is having a direct bearing. So k value we have checked in case of MCN. Okay, so small r is equal to capital R by k. If k value is big, at that time small r it becomes small. Okay, in that case small r becomes very less. In that case the transmission power required will be very less. Okay, so how much is the transmission power to be used at every hop? A very important feature in case of any ad hoc network. Okay, so that has to be controlled. Mode switching and selection. So whether the network will be working in the ad hoc mode or cellular mode, and when to switch. So maybe half of the time it is working in the ad hoc mode, sorry, cellular mode, and node has suddenly become mobile. Okay, so ad hoc node might not be used in that case because node is trying to go to the other cell. Okay, in that case suddenly from cellular mode the network will switch into ad hoc mode. Okay, so when to switch and why to switch and how much will be the gain in switching, that has to be understood by the base station before switching. Packet scheduling, reordering the packets to introduce the property of fairness or priority. So packet scheduling is mainly because every node or every source should be given a fair share of the channel so that it can transmit the data from the source to the receiver, and no packet should be lost. If there is a retransmission, that has to happen fairly. There should not be any congestion of data. Okay, so all those things has to be checked while packet scheduling. So these are four major issues of resource management in open issues in ad hoc, sorry, in next generation hybrid network. That is channel allocation, power control, mode switching selection, and packet scheduling. So important issues. Remember this four resource management issues in case of any hybrid next gen network. Next is load balancing. We have checked in case of multipath. We have seen what is load balancing. So don't use one path repeatedly between source and receiver. If there are some four or different paths, try to use each path, okay, at a different time slot. That will actually help to keep the network battery resources intact, and that will help. Some nodes will not get drained. Okay, some path will not die down. Okay, so that, and proper allocation of load balancing strategy will increase the node lifetime. That will increase the network lifetime. So in load balancing, what it says is in the hybrid architecture, the locality of traffic, okay, the fraction of calls originated in a cell that terminate in the same cell. Okay, the locality of traffic influences the capacity that can be achieved by the system. The system capacity increases with increasing locality of traffic. With low values of locality, the BS gets saturated early. Okay, so if some very closer node is trying to send too many data to the base station will get saturated. Okay, that is what is called as locality. So base station gets saturated early, affecting the maximum achievable throughput of the system. So if base station is saturated, in that case, the whole network becomes down because base station should be kept always as free as possible. The same thing happens. We say that our laptop is going too much into hanging state. Okay, laptop hang ho gaya. What is meant by that? The processor is too busy in solving the task or in performing the task that is given to it. So maybe the processor can solve 10 tasks in a second, but we have allocated 20 tasks for that processor in every second. So what will happen? Processor will get hang. Okay, so base station is kind of the central processing unit within any cell. Okay, so for this local effect or locality of traffic, the base station should not get saturated. That is very important. Okay, this will affect the maximum achievable throughput of the system. Obviously, the whole cell output will be affected badly if the uh, base station is saturated. So load balancing might increase the output by rerouting the calls originated by the nodes at the boundary of the cells through the neighboring BSS. Okay, so there has to be strategy. So if one base station is getting saturated, it should be able to share the load with other base stations so that it will be remaining free. Okay. Also, intelligent routing can be used to avoid going through the base station when even when the call is to be terminated outside the cell in a neighboring cell. So not necessarily that one call which is generating in that cell will get terminated in that cell. That means source and receiver can be within the cell, source and receiver can be into different cells. Okay, so in that case, that source will be contacting the different cell base station by means of base station of its own cell. Okay, so like we have seen in case of uh, the last type, that is soprano, that is you can just check here, that is this B. Okay, so this B is talking to BS1. Okay, and suppose there is another node here. Suppose this B wants to talk to this node. In that case, what will happen is B can talk to base station can send data here, and this can send the data to the this node. This is one way. Other ways, B can give the data to the base station will give the data to other mobile host, and they will invariably contact to this thing. So this is another thing that can happen. So we can use a mix and match of uh, ad hoc and cellular based network, okay, for the load balancing purpose. So always our main aim should be the base station should be kept as free as possible. So that's why it is said that intelligent routing can be used to avoid going through the base station even when the call is to be terminated outside the cell in a neighboring cell. In this case, the call can be completed through multiple hops through the boundary of the cell. That is what just now I had said, that in that case do not disturb. So if this B wants to send data here, in that case not necessary to use the traditional path, that is B to BS1, BS1 to BS2 by hotline, and BS2 to downstream. This is the traditional path. Second approach is B to base station 1, and base station 1 just send the data to R3, then R3 to R4, then R4 to R5, then R5 to R6, and maybe R6 to this station. So in that case, we are avoiding too much uses of base station 1 and base station 2. So we have to keep the base stations as free as possible. So in this case, the call can be completed to multiple hops. The number of hop count is increasing. Okay, previously B to BS1, BS1 to BS2, and BS2 to destination node. Only 3 hops were there. In this case, if we are using ad hoc mode, number of hops are increasing. Okay, but in that case, the base stations are actually kept free for bigger or more difficult work. So load balancing is one of the primary objectives of the ICAR architecture. Okay. There are some more things, that is these are the issues, open issues in case of hybrid next gen network. So first one is network partition. So network partition happens when within a cell the lower portion and upper portion are partitioned, because the lower portion nodes cannot communicate with the upper portion node. Okay, it might happen because of mobility, mainly the partition happens. Okay, so in case of next gen hybrid network, partitioning should not happen within a cell. Power control we have explained, that is the value of k, that is small r, that is a data radius, small r is equal to capital R divided by k. So more is the value of k, less will be the value of small r, and less will be the transmitted power. So k value we have to choose very judiciously, that how much we want should be the radius of the ad hoc data communication range. Okay, so that we have to select very judiciously. And routing protocol, there are different routing protocols we have checked. So prediction based routing protocol is one very important thing. Okay, that will help us in predicting where the mobile node is going to end up. Okay, so that will help us actually to keep the link intact between the source to the receiver. So very smart kind of routing protocols for congestion control, for link failure prevention, for route maintenance we can use. Efficient dissemination of control information. So control overhead should be as less as possible. So for that, again, very smart kind of protocol has to be written, and that should be having lesser amount of control packet, and that should increase the throughput, or that will maximize the bandwidth usage, and that will reduce the power usage of the network. So efficient dissemination of control information, control packet is very important. Path reconfiguration mechanisms. I told you that if we are thinking, or if you're able to estimate that there is going to be a path break due to a high mobility of some node, okay, so before the path breaks, try to find a reroute. Don't wait for the path to break and then start rerouting. No, before the path breaks due to a high mobility of a node, try to find out what is the reroute path. And as soon as the path breaks, or even if there is huge mobility in any node, just shift the control from present route to another route. Okay, so safety and stability of the route is very important. Okay, so very fast rerouting or rejoining mechanism has to be devised, and very smart and predictive kind of rejoining mechanism has to be devised. That is actually what called as path reconfiguration mechanism. So don't wait for the catastrophe to happen. As soon as there is a chance that yes, one path might break, try to reconfigure, try to find another reroute, and connect the source to the receiver through that reroute. Okay. And support for multicast routing. So multicast routing is a difficult thing because there are many sources, many receivers, and there are many nodes inside the network which might be used by some 2 3 different paths. So there is a big possibility that that node will get exhausted very soon, and all the links will be in a failure state. Because if there is a pivot node through which some 3 4 different routing is happening, 3 4 different sessions, data transmission sessions are happening, it is very likely that that node will be discharged very fast. And if that central node is discharged very fast, in that case all the 3 4 links will be of no use. Okay, so sharing of load in case of multicast routing, selection of proper route in case of multicast routing, some predictive location based routing for predicting if there is high mobility, if there is a path breakage. Okay, so all these things fall in the multicast routing related thing. So these are mainly 12 issues. 6 I have explained in detail, and 6 you can find out in the book of Murthy. And this is all about today's lecture. So next day we will start with our previous topic. So the topics were shown to you